Hello, welcome. We're going to continue talking about reflections in this video. You've learned how to reflect in vertical and horizontal lines in the coordinate plane. And now what we're going to do is we're going to use patterns that appear whenever you try to reflect in special lines in the coordinate plane. And when I talk about special lines, there's four of them that I'm referring to. There's the x-axis, the y-axis, the line of y equals x, and the line of y equals the opposite of x. These are patterns that you're going to learn that you have to know. And they're also very easy to use, by the way, so it's not a big deal to learn them. All right, well, let's start off with axial reflections, which just means a reflection in an axis. And so reflecting in the x-axis, reflecting in the y-axis is what I'm referring to. And I've put up a couple of sample points, P and Q, on each of these graphs. And what I want to do is I want to show you the pattern that occurs whenever you reflect a line in the x-axis, what happens with the coordinates of these points, and then same for what happens whenever you reflect those points in the y-axis instead. And we're going to write that pattern out in coordinate notation down here. It'll be a very simple pattern. All right, I'm going to start off actually by writing the coordinates of each of these points on the screen. Then how about we go and do the image in purple? Why not? Okay, now you've learned that whenever you reflect in a horizontal line, which the x-axis is, that all you have to do is reflect the point in equal distance below or above the line compared to where it starts. So for instance, P is 2 units above our line of reflection, so its image would be 2 units below the line of reflection right there. And the coordinates of that point would be -3, -2. And then Q is 1 unit below our line of reflection, so its image will be 1 unit above the line of reflection right here. And that's at +2, 1. Now there's a very simple observation that I want you to make about the relationship between the coordinates of each of these 2 points and their images, there and there. Let's look at point P first. When we reflected point P in the x-axis, notice that the x-coordinates for these 2 points are still the same, and the y-coordinates are opposites. One was +2 and one was -2. And that exact same pattern occurred with point Q. When we reflected in the x-axis, the x-coordinate didn't change, but the y-coordinates, they're opposites of one another. Now think about it. When you reflect in a horizontal line, the reflection goes directly up or down. It's a vertical reflection in a horizontal line, right? And so the x-coordinate's not going to change. But the y-coordinate will change, so they'll become opposites because, well, they're equal distances on the opposite side of the axis. All right, now what's the pattern then for reflecting in the x-axis? Well, any point xy, when reflected in the x-axis, is going to get mapped to a point that has the exact same x-coordinate as the pre-image did, but its y-coordinate is going to be the opposite. When you reflect in the x-axis, keep the x-coordinate the same, change the sign of the y-coordinate, and you'll have the image that you're looking for. Very similar pattern for the reflection in the y-axis. When we reflect point P in that vertical line, that's, since it's 3 units to the left, its image is going to be 3 units to the right. And that's at +3, 2. When we reflect point Q in the y-axis, since it is 2 units to the right of that line of reflection, we're going to end up with an image that's 2 units to the left right here, and that's at -2, -1. Now hopefully you see the pattern here. Whenever you reflect in the y-axis, since that's this vertical line, the reflection is actually a horizontal one, right? You're moving horizontally. And when you do that, you're not moving up or down at all, so the y-coordinates end up staying the same. You notice that P and P prime have the same y-coordinate, and that Q and Q prime have equal y-coordinates. But what does change is that the x-coordinates become opposites of one another, right? Here the x-coordinate was 3 and its image was -3. Well, I said that backwards, but 3 and -3 are the right signs. And here the pre-image has an x-coordinate of 2, image is at -2. So when you reflect a point in the y-axis, what happens is that you get the opposite x-coordinate from what you started with, but the y-coordinate stays the same. All right, so maybe here's the way to think about it. If you reflect in the x-axis, the x-coordinate stays the same. If you reflect in the y-coordinate, or y-axis, the y-coordinate stays the same, and the opposite one switches signs. We'll come back and see if you can use that here in a little bit. Now there's 2 other special lines we want to reflect in, and those are these lines you see on the screen now. the line y equals x, and the line y equals the opposite of x. Now you need to know the graphs of these lines, especially y equals x, and if you know that, the graph of line y equals opposite of x is not difficult. And the reason why I say that, and furthermore, I will say that you need to know how to reflect a point in these lines, is because in algebra and later math classes, when you're working with inverse functions, this is a very important line to be able to reflect in. Okay, now there won't be as much logic applied to my explanation here of how you get the image of a point reflected in the line of y equals x, because there's not a logical way to reflect in diagonal lines necessarily. Okay, but there is a pattern that works with these two that you're about to learn right now. I'm going to go ahead and just show you what the image of point P would be and what the image of point Q would be in each of these situations. And then I'll show you how it's in the correct location and what the pattern was that I used in order to find that location. Let's start with P. Turns out whenever I reflect P, negative 3, 1, in the line y equals x, that I'm going to get the point 1, negative 3, right here. For now, I hope you can just visualize that those are reflections of one another in our line of reflection. And then point Q, which is at 1, 3, its image is going to end up being at 3, 1 right here. Now, I did a very simple thing in order to reflect each of those points. All you have to do whenever you're reflecting in the line of y equals x is you switch the x and y coordinates of the points with one another. So you see here I had negative 3, 1, and then I just switched the order to get the image, and I got 1, negative 3. Started off with 1, 3, I switched the order of those two numbers, and I got 3, 1. That's how you reflect in the line of y equals x. Every point xy gets mapped to y, x. Switch the coordinates. Now let me show you on why that works. If you remember the properties of reflections that we learned back in the previous video, then this will make a lot of sense to you. If I were to connect point P with its image and point Q with its image by drawing segments between them, what you're going to notice is that the line y equals x is the perpendicular bisector of each of those. All right, you can see that that is a right angle, you can see that that is a right angle, and this distance are equal, this distance and this distance are equal. So, we definitely had the correct reflection there. Okay, now when you reflect in the line y equals the opposite of x, a very similar pattern is going to occur in which we're going to be switching the order of the x and y coordinates. But there will be something additional that we do whenever we're reflecting in y equals the opposite of x. Let me go ahead and write the coordinates of these 2 points, and then I'll show you their images, and we'll talk about how I got that. Now what's going to happen here is that a point negative 3, 1 is going to get reflected to negative 1, positive 3 right here. And the point 1, 3 is going to get reflected to negative 3, negative 1 down here. Now again, if I connect each point with its image, you ought to be able to see the symmetry there. All right, so you can tell that the reflection worked. What was the pattern that I did? Well, when I reflected in the line of y equals opposite of x, I still switched the order of the x and y coordinates, but I also changed the signs. Instead of having a negative 3 first, I had a positive 3 second. Instead of having a positive 1 first, I had a negative 1. Sorry, instead of having a positive 1 second, I had a negative 1 first. All right. Same thing happened here. I switched the order of these 2 points, and I switched the signs. That's how I reflected in that line. So always when you reflect in the line y equals the opposite of x, you're going to switch the order of the points x and y, but you're also going to make them the opposites of what they were originally. Alright, so 4 patterns that you need to know. The pattern for reflecting the x-axis, in the y-axis, and in these lines y equals x and y equals the opposite of x. Now let's go ahead and do a quick couple of examples where you're going to apply some of these patterns. We're not going to have time for all of them, but I think you'll get them without me having to show all of them. We're going to graph the reflection of this polygon in the given line, and we're going to start off by using the line y equals x. So you should take the time to copy this picture down, and then we'll go through and actually do the reflection. Now, it would be imperative for you to know how to actually graph the line y equals x before you're able to reflect in it, really. Well, you know the pattern, but we want to see that this works out. When you're graphing the line y equals x, you're graphing every point that has an equal x and y value. So, for instance, the point 0, 0, the point 1, 1, the point 2, 2, or negative 1, 1, or negative 2, negative 2. Any point that has an equal x and y coordinate is on this line. So there is that line y equals x. And what we said we're going to do in order to reflect in that line is we're simply going to switch every x and y coordinate for the points that we're reflecting. So point K is going to reflect to 1, negative 4. Or rather, negative 1, negative 4, because that was supposed to be a negative 4, negative 1 right there. So here's K prime. Switch the coordinates for L. We'll get L prime at 4, negative 2. M is on our line of reflection, so it's not going to go anywhere when it's reflected. You switch 3 and 3, you still get 3 and 3, right? And then point N will reflect to negative 3, 1. Connect those, and you've got the reflection of that quadrilateral in the line y equals x. Can you see the symmetry there? Excellent, hope so. All right, one more example, then we're done with this video. This time I want us to reflect this triangle in the y-axis. And so what's the pattern with the y-axis? Well, we said when we reflect something in the y-axis, we're going to just make its x-coordinate the opposite. The y-coordinate will stay the same when we reflect in the y-axis, and the x-coordinate will become the opposite of what it was. So that'll give us x prime here, w prime here, and v prime here. And I'll write those coordinates down. Voila, there's our reflection in the y-axis. Very simple to do. So you just have a few patterns that you have to remember to reflect in these special lines. The axes, y equals x, and y equals the opposite of x. Very simple to apply. All right, guys. Thank you. See ya.